We're going to do notes a little bit differently today. I'm going to show you a PowerPoint where I've pulled together some examples to talk about those special parallelograms that we were just examining in the original notes video with my hand-drawn information and the hierarchy of your parallelograms. So we're going to be looking at specific examples and finding values of variables. In the first diagram, it asks us to find the value of x in the figure, so take a look at what's shown there. The fact that we have 4 congruent marks shows us that this figure is going to be a rhombus, so now we need to think about what we know to be true about a rhombus. The x is marked in a portion of the angle that is next to 68 degrees. So x is not the whole angle. If you look over here, x is just that portion of it. But this whole angle that I have marked there with a red dot, and then this whole angle over here with the orange dot, those two together are going to add up to 180 because they're next to each other. So they're going to be consecutive. That means they're supplementary. So 180 minus 68 tells us the entire angle over there at the red dot is 112 degrees, not the value of x. The whole angle is 112 degrees. Now we have to remember a property that is specific to the rhombus. One of the properties of the rhombus is that the diagonals bisect the angles. So that, what I highlighted there as a purple diagonal, it's going to cut that 112 degree angle in half because it's going to bisect it. So x is going to be half of the 112 degree angle. So x will equal 56 degrees. In our second one, this is an error analysis question, so we have to figure out what this person did wrong. Error analysis, find the error below in solving for x in the rectangle. So first of all, notice we are told the shape is a rectangle. The student made an equation saying 9x equals 27. So let's take a look at where those two things came from. If I highlight with dots where the 9x and the 27 are, they're here and here. And if you will notice, those are in the same triangle, if I use that diagonal as a cutter. And those two angles are not going to be the same. They're on the same side of that diagonal, which you could think of as a transversal between your two parallel sides. So those two are not congruent. So I guess the question becomes, what angle is the 9x congruent to? So if we take those dots off and think about that 9x, what would it be congruent to? Well, it's definitely going to not be the 90 degree angle up here. So if we think about this triangle and this one, we know they're congruent because of hypotenuse, leg, or side, angle, side. But we know these two are going to be congruent. So this 9x, it's not congruent to the one right next to it. It's going to be congruent to this one over here. So that's the location that's congruent to the 9x. Well, that's great and all, but we need to look at what does that alternate interior angle equal? What's its measure? Well, we know that in a rectangle, all angles are 90 degrees. So this entire angle right here, the whole thing, not the red dot, not the 27, but all of it together, would equal 90 degrees. And this bottom part is 27. So I should be able to do 90 minus 27, and the red dot zone should equal 63 degrees. So that would mean our equation, the 9x over here where the red dot is, that's also got to be 63. So the equation should be 9x equals 63, in which case we could divide by 9 and get x to be 7. All right, find the measure of angle 1, the measure of angle 2, and the measure of angle 3. That little m in the front means measure, and we just read it that way. We don't say m angle 1, we say measure angle 1. All right, so let's take a look at our shape. What do you notice? What do we have? Well, the markings on all 4 sides being the same tell us that this is going to be a rhombus. So now we need to think about some of our rhombus properties. One of those properties is that the diagonals are perpendicular. So where the diagonals connect, right here where angle 1 is, all 4 of those angles are 90 degrees. So we know the measure of angle 1 is 90 degrees. Another property of the rhombus is that the diagonals bisect the angles. So the only angle we have marked is actually this 55 degrees right here. And I know that this diagonal bisects that. So if this is 55, then this down here would also be 55. That means the whole angle, I don't have a name for it because there's no letter in there, this whole angle would equal 110 degrees. Now remember, this is still a parallelogram. So if this angle is 110, then the opposite angle up here would be 110 degrees. And the diagonal bisects the angle. So angle 2 is going to be half of 110 degrees. So angle 2 will measure 55 degrees. So what we have left now is angle 3 over here. So I went ahead and put the 110 degrees on each of those two angles because I think that's going to help us. So if we mark those angles, we're going to see that this angle over here, not just the 3, but where we have the 3 as a part of that whole angle, this angle is next to the 110. And we know that consecutive angles, as we go around the shape, need to add up to 180. So this angle up here, not angle 3, but the whole angle, is going to need to be 180 minus 110. So that big angle would be 70 degrees. Now, I also know that in a rhombus, the diagonals bisect the angles. So if this whole angle is 70 degrees, then this, where angle 3 is marked, will be half of that because the diagonals bisect the angles. So half of 70 is 35. So the measure of angle 3 would be 35 degrees. Our new question says, find the length of segment AC in the rectangle if AC equals 6x plus 3 and BD equals 4x plus 19. Well, the first thing I noticed was it told me this is a rectangle. So that's important because there are some properties that are true specifically of a rectangle. One of those is that the diagonals are congruent. AC and BD are diagonals. So that tells me they are congruent to one another. So the length of AC should be the same as the length of BD. So if I take each expression and plug those in, I get 6x plus 3 equals 4x plus 19, and we'll solve those out by subtracting our 4x, getting 2x plus 3 equals 19, subtracting our 3, getting 2x equals 16, and dividing by 2 to get x equals 8. Now notice the question did not say find the value of x. The question said find the length of AC. So if I go back to the reading, I see that AC is equal to 6x plus 3. But I know now that x is 8. So I can say 6 times 8 plus 3. 6 times 8 is 48, and 48 plus 3 is 51. So AC has a measure of 51. Find the value of each variable in the rectangle. So again, we are told specifically that it's a rectangle. So let's think about rectangle properties. One of those, it's the one we just talked about, is that diagonals are congruent. The other one is all angles in the rectangle itself will equal 90 degrees. So the first thing I'm going to do is the fact that it's still a parallelogram. So the diagonals bisect each other, but because they're congruent, all four are going to end up being the same measure. So I've put those little tick marks on there. Now I've created a red triangle on there for us. That red triangle is going to give us two pieces of information. I clicked ahead accidentally, but it's okay because they both deal with this red triangle. So that red triangle is an isosceles triangle. Let me get my cursor over here. This length is marked as congruent to this length. So therefore, those two are the same, and that makes it an isosceles. In an isosceles triangle, base angles are congruent. So 51 and x, the ones that are opposite the congruent sides, are going to be congruent. So if this is 51, then x is going to be 51. The other one that we can do with this same red triangle is W, because we know that in a triangle, all angles will add up to 180 degrees. We know this angle is 51, and we know this angle is 51. So 180 minus 51 gives us that angle W right here, part of the vertical angle, is 78 degrees. The only variable we have left now is Y as far as angle measures go, and then we have a Z that occurs on some sides. So when I am trying to think about this y right here, I probably need to focus on a different triangle. So let's take a look at a different one. Let's look at this purple triangle, the one that y is inside of. This is also an isosceles triangle. I can see I have a marking here, and y and this empty one are going to be our base angles. So if I can figure out what belongs up here, then y is going to be the same thing. So it's important for us to remember that the angles of a rectangle will always be 90 degrees. So I've put a marking on there. It wouldn't let me really mark a square thing very well, so just understand that that's a square for our 90 degrees. Now remember, x is 51 degrees. So 90 minus 51 should tell me what this portion of the purple triangle is. So that would be 90 minus 51 is 39. And since this angle and y are base angles, that means that y would also be 39. The last variable we have is z. Z occurs up here on this side and this side. Those are opposite sides. And it's still a parallelogram, so opposite sides are congruent. So that allows us to put those two equal to each other. And I didn't write out all the solution steps, but I subtracted 8z, added the 48, and ended up dividing by 6. So we get z to equal 9. And find the value of each variable in the figure. So let's take a look at that figure. We will notice that we have the tick marks on all four sides being the same. And we have indicated there that that makes, by the way, a rhombus, all four sides the same. And then because we have a right angle, we know all of the angles would be right because opposite angles are congruent. So these two would both be 90. And consecutive angles have to add up to 180. So 180 minus 90 is another 90 over here. And that means this one would be 90. So all of the angles are going to be 90 degrees. Because of that, this whole angle right here will be 90 degrees. But even more specifically than that, in a rhombus, which a square is a rhombus, the diagonals bisect the angles. So this is going to cut that 90 in half. So half of 90 is 45. So 5x has to equal 45. That allows us to say x is 9. Then the y happens to be on some sides that are the same because all the sides are the same. So 5x plus 15 and 7x minus y need to be equal to one another. We solve that by subtracting 5y, then adding our 9, dividing by our 2, and we get y to equal 12. All right, I hope that that has helped you as you think about those figures and where each of those is going to assist you in finding your shapes. If you are finding variables in your shapes, if you have any questions, let me know.